Hello everyone and welcome to a new episode of All Things IDA. Today we'll learn how we can store information and retrieve it later from the database. To achieve that, we'll be using a system called netnodes. It's the storage facilities inside IDA that actually IDA kernel uses as well to manage the database and so on. So we'll be talking about those APIs, how we can access IDA information at the low level. Then we will use netnodes correctly to store our own private data without colluding with IDA kernel. All right, so let's get started. As usual, let's get started with the SDK. So what we want is netnode.hpp. This is where we have the netnode API. So netnode, if we quickly jump to the netnode class is what we will be working with. It allows us to create a node object and then address into it to store the information. So at a high level, we can think of a netnode as a three-dimensional array. So a netnode is a three-dimensional array, and we need to specify 3 indices in order to access the information. The first index number is either 32 bits or 64 bits, depending on the bitness. But since IDA 8.3, we will have a single bitness. We will no longer have to work with EA64. So the first index is up to 64-bit. Then we have the second index, which is a number, and it is referred to as tag. That tag has special value, and then we have different semantics depending on the tag value, how we want to treat this netnode object. So for example, we have a bunch of predefined tags. For example, we have a tag, value A, is for alt val. Usually the alt specifies numeric values. The SUP for buffers and strings and so on. And these are other internal tags for IDA. So the tag, we give it a value. There are special values. And a third index as well, arbitrary third index. So this is what makes up a netnode. So if you want to store information up to 1 kilobyte, then of course we can store more. Then we'll have to be clever about it or use some functions for that, like blob storage, which also uses netnodes. But if we want to store a piece of information, we need to provide 3 indices to store the information. Depending on what kind of information we want to store, if we want to store a number, we can use the altval altset method. So altval method in the netnode retrieves a value from the alt tag, given the index that you specify, the third index. And same alt set is the opposite, basically. We open the netnode, so we have the first dimension. It's alt, so we know it's the A tag, so we have the second dimension and the user specified alt index, and then the value we want to store. So let me explain a bit using the code. So for example, here we say the API.netnode, and we need to give it the first dimension at creation time, or we can open a named netnode. So we're going to talk about the first dimension. We have as well some helper constructors where we don't have to pick the first dimension by hand. So if we want to store a piece of information right now, so that's not the right way, we're going to show you a better way, but just quickly. So here I want to store the value, let's say value that I want to store is 1, 2, 3. So I create a netnode. I have to specify the first index. Let's say I'm storing at some index, for example, 4. Maybe it works, maybe not. We'll see. But that's the first index. Now I want to store a value, so I'll say n. Now in reality, if you think of netnode as a global array, you will think, okay, so I want to store it at this first index. I'm gonna pick another arbitrary address and let's say another arbitrary address and put the value 1, 2, 3. And that's fine. That's how netnodes are used to store. But we don't directly pass the indices like this. We have to use the helper methods. So since we're storing a numeric value, we specified the first dimension. We're going to use the A tag, and we'll pick a third dimension, any arbitrary value. So here we say alt set. The third dimension, I don't know, let's just store it, let's say, fine as it is suggestion. And then let's clear the value just and try to retrieve it again. So as long as we specify the same third dimension and the same tag and the same netnode index, we should be able to retrieve it. Okay, so let's try it out with IDA on the side. All right, I'm going to save it, and hopefully we should see the value 123 retrieved back for us. Here we can see the value 123. But there are so many problems with this approach. Now, indeed, we stored the number, but there are a bunch of issues. Netnodes are used by IDA to store information about the database. And IDA uses this in a specific manner, using a certain convention. So the risks here is we open the first dimension at 4, and this, and so on. We might be risking overriding stuff that IDA kernel uses. So the suggestion here in the header file is to use named netnode. If you want to use netnodes for your own information, for your plugin and so on, use the $sign prefix or some other prefix that is not an identifier character. So we let the kernel pick a unique name that a unique index that will not conflict with IDA. So what do we mean by conflicting with IDA? IDA conventionally uses netnodes to store information about the addresses and type info and comments and stuff like that. So for example, conventionally, when IDA stores, let's say, comments or operand representation and cross-references and so on, not flags. Flags are stored somewhere else. It uses the first dimension coinciding with the address. Then, depending on the kind of info, it will pick the tag, and that will be an arbitrary address. So if we want to use netnodes to retrieve this comment, so store one, let's move this out of the way, and now let's read this comment here. So the first dimension is going to be coinciding with the address. So let's just take this. Now let's create a netnode. We're gonna open the netnode, given the first dimension to be the address, and since we're storing a string, we know IDA will use the SUP tag, so that's the second dimension. Now we need to know if we're retrieving repeatable comments and non-retrievable comments. So we need the third dimension that will be describing which comments we want. So real quick, here I will press colon. This will open the regular comment window. I also put a repeatable comment at the same address, which you will not see because IDA prefers the non-repeatable. So I'm going to press semicolon, and I have another repeatable comment at the same address. So let's use netnodes to retrieve repeatable and non-repeatable. So far here, I can say print n.supval. Now, what is supval? Instead of alt nodes, we're reading from string tags and so on. So what does the supval require? Basically, it already passes the S tag, so by default, but it needs one more dimension, the third dimension, in order to refer to a netnode. Luckily, IDA gives us a lower level header file called an alt. And this is internal in IDA source code, but it so happens to define the indices for reading the comment at a low level. So NSUP comment 0 and repeatable comment 1. And we can actually use the constants. So we need the third dimension. I want the non-repeatable comment. So here I'm just simply saying, let's show you the SUP val. So SUP val takes, already the node is open, so we have the first dimension. Alt tag, alt is here is the third index, and the tag is gonna be by default to be the S tag. So this should be complete. All we needed is just the third dimension to be passed. Let's clear the screen and see if this address here, we can read the string buckets and retrieve the convention that we use to store the comment. So using this convention, we should be able to retrieve the comment. Let's see. And here we got, this is the comment. Now let's retrieve the second one, which is the repeatable. So here, let's just also print this one. And now we have repeatable and non-repeatable comments. It's not advised to use those at the lower level. So here I'm gonna call this test like a hack. We're not supposed to be playing with this. Instead, if I really want the comment here, all I have to do is IDAPython.getCMT and give the address. Let's say regular comments and repeatable comments here. So we're using the get comment method. Repeatable or non-repeatable. So last, let's go back to revisit store one. Now we got the concepts correct. Let's talk about properly using things. So I'm gonna fix this example. The problem we had was mainly we learned that the first index can coincide with an IDA address, and we might be accidentally overriding IDA information. The convention in IDA is to start to create the named net node. So we create a net node object as it is with no specs, so we didn't really yet open it or set it up. And then we say node.create, and we give it a name. And here I'm going to say my plugin, or let's say my test script. Of course, here you give it a long, unique name for your plugin. So by doing this, let's print the node index. And like this, you see it will create a unique node index, and you can always rerun the script. You'll always get back the same index given the same net node name. So we're gonna display the node index. So that's the node index. And now let's call this. Let's always clear the screen. Okay, so this is the correct way now we can use the net nodes, is giving the named node. And then we can display what IDA will assign. Now, based on documentation, IDA will give us a hint as well. When we use named net nodes, it will start to use higher address ranges, which are less likely to be colliding with program addresses. Okay, so that's store 2. It's gonna now store 1, 2, 3, but this time not picking a dangerous address. Okay, let's test it. So save. And let's display maybe the node index as a hex, so it makes better. But as you'll see, we got 1, 2, 3. Let's now not set it anymore. So what I'm going to do is simply read it. So I'm not gonna ever set it. I'm gonna simply load, open a net node, open it by name. Let's access the alt tag, because that's where we store numbers, and let's use index 1 to retrieve value from third dimension 1. If I just rerun this, I should get 1, 2, 3, although I never really set it. So let's run it. And let's also display this number in hex just for, so it took here the name net node got FF and so on and 283. So now in the loading part only, we should get the same information. So we got the same net node index, and we managed to read the value. So now let's store strings. For example, let's say n dot sup set. We need to give it an index. That's the third dimension. Since we started with our named one, so let's just make some convention. So what programmers do is they say, okay, we're gonna define pass, for example, let's say net node ID of the pass string, let's say, is one. Net node ID of option flags equals 2, for example. Net node, for example, ID index of, let's say, name equals 3. And here, let's say this is store state. Let's make a state object. Let's store this information. So let's also take here and give the name a variable. So node name. Okay. All right, so create a net node. Now we need to store the values. Sup set, so we want to store a string. We're gonna use the net node index of pass, so like this, we do not mess it up like that, that's it. We wanna store the options flags, but since they are numbers, let's give them some value here. Then we cannot use the sup, you're gonna use the alt to store numbers, and we're gonna store the options flag, and for the name, we're gonna use the sup tag to store the name. And you'll notice, since we're using a different tag here, in reality, this could have add index 1 and this has index 2. Since those two will be in the same bucket, we're gonna be in the S tag, and this will be in the A tag. And so that's why we are reasoning correctly. Def restore state. It gives us a state back. So we create the object. We retrieve from sup tag as a string the same index we stored at, the same index we read from, the same alt, and so on. So let's run it 2 times. First time we're gonna store, then I'm gonna display it. So let's just make here something like str. And let's maybe print a message here. So here we go, we stored this. Now, if I save the database, now let's restore it. So our plugin loads, now we wanna restore it. In that case, I don't need all of those, just format it. All right, now let's open the same database. We don't have the info. Let's see if the script is active, okay. All right, let's run it. This should give us the same information. All right, save. Here we go. And so if you're writing a plugin, that's what you will normally be doing. You will have a state object. You will have a set of node IDs where you'll be using this information. Okay, so we covered how to store basic stuff, but what if you want to store blobs, bigger stuff? We do have as well helper methods to store arbitrary sized information. Now, this is not magic. By specification, the net node can only store up to 1 kilobyte, but we can store bigger info. So what happens really behind the scenes is when we want to use blob storage, IDA will give us some helper methods where we can basically use the third index and subsequent indices to store the blob. So we will be telling IDA the first 2 dimensions, and then so we can pick any tag, a user named net node. But then for this, we tell IDA starting a blob index, and it will start to break the blob into as many pieces as it needs. And it stores the blob. Then for retrieval, we give it back the starting blob index, and it will read as many subsequent buckets and reformulate the blob for us. So we can store arbitrary size stuff. Now, in the example I showed you here, we are storing elements one by one. If you wish, you might want to pickle and then store the whole binary representation into a netnode blob. That also works. It's not necessarily update proof, but it's efficient. So for the netnodes, we have the blob methods. Now this is a retrieval of a blob size and so on. So set blob. Now in Python it will be different syntax, but in general, this is a netnode method. That means the first dimension is already set up. We still need 2 dimensions. So this is the blob. This is the tag, that's the second dimension, and that's the start index of the blob, that's the third dimension. Okay, so let's conclude by testing blobs, how to work with blobs. So instead of serializing field by field for the state, let's import Pickle. And we're gonna store this using Pickle. So we're gonna restore it as well similarly. So let's say store state Pickle. We create the node, and now it's a different story. We don't need multiple net nodes and so on and so on. So let's create some node here, node index. We don't need the other ones anymore for now. And let's call it state, just the whole state, the whole thing in the state. So open the node here. A node object, create the net node. And now what we want to use is set blob. So let's take a look at set blob. So I already have a dummy net node object created. Here I'm just querying the set blob method. So set blob requires the buffer we want to store, the start basically is the third dimension, and from start +1 +2 +3 we will store the remainder of the buffer. And tag is just up to us. We can use SUP tag or something. So set blob, the buffer, and this looks good. So we're gonna use the pickle library to dump the whole thing as a representative string here and set it into the blob. Here we can also say pickle. Okay, so let's store the state using pickle. So here, let's just make some differentiation. So node, open the name net node, pickle the information, store it as a blob. Okay, we have one more parameter. We said the buffer is the data, the start is the start, and the tag, let's just use, I'm gonna use the, just an arbitrary x tag. All right, save. So here we go, we got the object state nicely pickled. Now let's restore the pickled state. It's gonna be similar, but reverse order. So same story, we open a net node. Now all we need is to depickle the objects. So the first thing is we need to take the data from the netnodes. Get blob is gonna return the bytes from the third dimension here and the tag, the same tag. We got it. Now we should create the object that state, and we're gonna reconstruct it from pickle.load_s, and we return the state. You might have, if you change the state object internally and so on, and so be aware of binary compatibility with respect to your objects and so on. So it's hard to manage this and keep updating your object versus the individual storage of fields is slightly more flexible. So restore state, pickle state. Okay, all right, let's try it. So this time I'm going to do the opposite and print it. All right, so we're going to save it and see here. We can see the differentiators, for example, the name, test pickle, and so on and so on. So these are the two strategies. And these are the real important things in the net node. Now you have other methods we can quickly go over, like SUP del, for example. It deletes all the SUP tags. So we can actually delete the whole dimension, so to say. We have exists. We can check if the net node we opened exists or not. All the deletion, so we can alt del, for example. We can delete all the alt values. The most important ones are string, blobs, and numeric values. These are the most common things. And finally, remember, net nodes were meant to be used by IDA kernel, and only if we use it correctly through following the correct convention of the named net nodes, then we can use it on our own. And finally, remember, this is gonna be in the database. They're not gonna be roaming. To store stuff outside the database, you can use the file system or the registry facilities in IDA. We can cover that in later episodes. But mainly, it's best to use secondary files on the file system. So that's it for today. I hope you found the net node coverage useful, and I'll see you next time. Thank you.